Now we know how the minimizing cost problem looks in the diagram, at least the tangency point. Let's look at what happens when you change one of the prices or when something else changes. Now the first thing I want to point out is that since this is a tangency point right here, right, then we already have an equation, we should have an equation for this line, because we know that the slope of the isoquant and the slope of the isocost are the same at that point. And we know that the slope of the isoquant is the marginal productivity of labor over the marginal productivity of capital. And the slope of the isocost is also equal to the ratio of the prices, which is W over R. Now, the two things are negative, so the negative cancels out. So what I'm saying here is that this equation that you have right here is a minimizing cost equation, and comes from this same graphical solution in which the tangency point of both the isocost and the isoquant is what give you the minimizing cost. The left-hand side of this equation is the slope of the isoquant, is the ratio of the marginal productivities, and the slope on the right-hand side of this equation is the slope of the isocost, which is the ratio of the price of the inputs. Now notice that you can also, if you have put K on the horizontal axis and L in the vertical axis, then the equation will be exactly the same, but all the things will be reversed. You have MPK on the top and MPL on the bottom, and you have R on the top and W on the bottom. But I'm going to continue to use the convention of having L in the horizontal axis and K in the vertical axis, so the equation is always going to look like this. MPL over MPK equals W over R. Now that you have this equation, it should be pretty straightforward to realize what is the effect on the minimizing cost solution of any changes of the variables. Let's say the price of labor increases, right? Well, the price of labor increases, we just have to look for where that is in the equation, and that's right here. So if the price of labor increases, the isocost, it becomes steeper. And if you're operating in the same isoquant, right, you're trying to still produce the same amount of output, what's going to happen here is that you're essentially going to rotate along the same isoquant, and you're going to end up producing the same output, but with a less labor and more capital. Which makes sense, right? If labor becomes more expensive, what the firm is going to do is going to replace some labor with some capital. All right, so you will end up using more capital and less labor because the tangency point will be at a higher point of the isoquant. On the same token, and by the way, this will be the same thing that happens if the rent becomes less, if the price of capital becomes cheaper. Now, on the other hand, if labor becomes cheaper or capital becomes more expensive, then the isocost, again, you're talking on the right-hand side of this equation, the isocost will become flatter, and what you'll have is that the tangency point, do this in red, the tangency point, looks so well. Let's see if we can do this a little better here. The tangency point will be at a lower point, right? So the tangency point will be at a lower point of the isoquant because the isocost is going to be flatter. And again, this makes sense. If labor becomes cheaper, then you will actually start using more labor and less capital. You replace some labor for some capital. Now, if there's any change in the marginal productivities, then you'll have a change in the isoquant, and we'll talk about that when we discuss the isoquant. But the main part or the main uses of this model is to see what happens to the tangency point if there's any change on the prices of the inputs. As you will see, if the prices of the inputs change, the isoquant, the slope of the isoquant changes, and you will end up either at a higher point of the isoquant or a lower point of the isoquant.